Good evening, everyone, and thank you for joining us for tonight's presentation. My name is Jeff Simon, the president of Social Flight. For those of you joining us for the first time, welcome. Social Flight is the web and mobile app dedicated to supporting general aviation, and we do that by helping pilots like yourselves fly more and experience everything that aviation has to offer, like tonight's presentation. The Social Flight web and mobile apps show you tens of thousands of aviation events, fly-ins, pancake breakfasts, FA seminars. We also have over 200,000 points of interest and attractions you can walk to from airports, and over 100 built-in videos and recordings of webinars just like tonight. It's all completely free to you. It's there to promote general aviation, and it's made possible by companies such as tonight's featured guest, Continental Motors. As an A&P mechanic myself, I'm especially excited about tonight's presentation because Lena Peak operations seems to remain one of the most passionate of operating topics, and certainly it's something that that mechanics get questions of on a regular basis. And so hopefully this is an excellent opportunity to learn about all different aspects of engine operations tonight and shed some light on that subject, and hopefully at least have a few of you breathing easier the next time you pull that mixture knob back, and maybe saving a little more gas as well. So again, thank you all for joining. And with that, I'll hand it over to Bill Ross, Director of Product Support and Continental Motor Services.
Thank you, Jeff, and good evening, everyone, again. I'm coming to you this evening from our MRO, Continental Motor Services, located in Fairhope, Alabama. And I want to say a special thanks to Social Flight making this possible. Social Flight is a very unique endeavor that certainly I and many of my flying friends use all the time, and thank you, Jeff, for making that available to us. And again, to those of you who have signed up to listen to me tonight, thank you for taking time out of your evening to listen to me, and so we can discuss engine management, engine flight management, and hopefully get a good understanding about how to operate our engines. Tonight's presentation is designed to make it simple. Certainly there is, as Jeff stated, there's a lot of discourse that goes on out there about how to operate your aircraft engine. There's a lot of unsubstantiated technical data out there that floats around, and I'm asked all the time, Bill, what do you think about this new Lena Peak? I've heard this all the time, and many of you have. Continental doesn't like Lena Peak, do they? And that type of thing. And I don't understand where that comes from. I've tried to understand it over the years. But the reality of it is that Lena Peak can be done very safely. It can be done without any damage to the engine, and the engines are tested to be durable in a Lena Peak configuration. There are some engines that are not designed to run Lena Peak, and their maximum efficiency is actually at peak. Some of the Continental engines, the maximum economy that you can get out of the engine airframe combination is at peak. We'll discuss some of that. And we'll talk about best power. You're not going to hurt your engine to go and run at best power either. There's a lot of myths out there about cylinder head temperatures and combustion pressures being an evil thing, and we will certainly discuss that and encourage you to ask questions regarding this topic. Again, it's designed to be very easy, this presentation, and to make it simple. There's probably lots of engineers and people out there that probably know a lot more about this than I do, but I've tried to keep it very simple. I learned to fly at a young age. I worked as a commercial pilot, as a flight instructor, as a charter pilot, and I've got a lot of time behind Continental engines. I came up in the era when fuel was $1.50, $2 a gallon, and airplanes were designed to go fast. and we flew them hard. We flew them at best power, and we utilized them as fast means of transportation. Also, through my flying career, I've seen fuel go to from $1.50 to $2 a gallon up to $6 and $7 a gallon. And certainly, if many of you are like my family, my wife has a different set of priorities with our checkbook than I do with regards to my avgas allowance, and therefore I look for ways to run more efficient. I am an aircraft owner, and I do understand the pitfalls and the ins and outs of aircraft ownership, and so I think it's important that we make it simple and we make it clear as to how Continental recommends that you operate their product. I've also divided this seminar up into, or webinar, excuse me, into two parts. And tonight, I want to plant a few seeds, get you folks thinking about some things. We're going to identify some basic definitions that we need to understand, and I'm going to introduce to you our Lena Peak simulator that we developed at Continental Motors to help aid pilots in understanding what exactly is happening in the engine when we set power and we start pulling on the red knob. So we'll jump right in tonight. We're going to, again, I've divided it into two parts. So we're going to go through the definitions and things like that tonight, and then next week we will really get into the meat of engine management and what's really going on inside the engine. Now, to review, my next slide here, I've talked about this before in other presentations, but as we move and we talk about aircraft engine management, it is vital that folks understand what we went through, what Continental had to do to certify the engine. It is extremely difficult, and the hurdles that one must go through now to certify an aircraft engine are extraordinary. For example, it would probably take us 5 to 7 years if we decided that we as a group tonight want to come up with a new generation aircraft engine that we're going to make available to original equipment manufacturers for new aircraft. We would probably be looking at 5 to 7 years of very, very hard engineering work and endurance testing through FAA Part 33. And we have to build in safety margins that are extraordinary with our product. We have to show endurance on the engine, and when we do that, we have to configure the engine at maximum engine limitations. So our endurance testing, our aircraft engines are configured for 460 degrees cylinder head temperature, 240 degrees oil temperature, and maximum inlet air temperature to the engine as we perform leaning curves and as we run the engine for endurance over a period of time to satisfy that FAA Part 33 for the certification. We have to do altitude performance as well with the engine. And most of all, what we're going to talk about tonight, and when we talk about the red knob and damaging our engine and being outside of spec, if you will, or outside of engine limitations, we're going to talk about detonation margins. And we have to keep you free from detonation so that anything that you do with the red knob, you won't detonate the engine. And we also have to keep a 12% margin of safety from the limits. And we're going to talk more about detonation. Torsional vibration, structural loading, Operations, we have to look at the different types of operations, conditions that the engine may be subject to. Extreme hot, cold, dusty conditions, things like that. So all of that is going into developing the engine and most of all coming up with one of the terms that we're going to learn tonight, which is max cruise power setting. So all of these things we have to go through. We do overspeed the engines. We do that purposely. We have to look at propeller integration. You know, many people out there are putting lightweight propellers on engines, and some of the propellers don't meet the minimum polar moment of inertia specification is set forth by Continental Motors, and the engine can emit some very nasty torsionals into the accessory drive train and the magnetos and things like that if we have a propeller that doesn't meet those specifications. Oh yes, it may be certified by the propeller manufacturer, but it also has to be integrated with that particular power plant. So you have to make sure, if you're unsure of whether or not a lightweight propeller that you're thinking of using will work or not, then you need to contact us at technical product support at the factory, and we can work with you and determine that. Instructions for continued airworthiness, or what we call ICAs, are another big part of this. We have to write that as part of the whole package when we certify an engine. So we're providing instructions for continued airworthiness. So when I'm talking about tonight, when we start talking about leaning, when we start talking about lean to peak, and we talk about best economy and best power and things like that, keep in mind that Continental Motors has to look at it from both a detonation margin point of view, so we're going to keep you free of detonation, but they also have to look at it from a durability point of view. So our power settings that we come up with, maximum engine limitations, are to keep you safe from detonation and to provide maximum durability. I'm asked all the time when I started as a technical service rep years ago at Continental Motors, and many of the technical service reps now field calls daily from owners and pilots. How do I fly my airplane? How do I fly my engine? How would you operate my engine? And the canned answer from the Continental Motors employee would be, as long as you're operating within the parameters of your pilot's operating handbook, you can't hurt the engine. Now, there are other ways that we can run the engine outside of those limitations. We'll talk about that, but we have to be very, very careful when we're going outside of that, outside of those limitations. As some people have demonstrated, there are classes who have demonstrated that you can run the engine outside of the limitations set forth by the manufacturer and do so safely. One of the classes that I think is very, very good is Advanced Pilot Seminars. Myself and many of the, well, actually all of the technical service reps at Continental Motors have attended that class. And a lot of good information. I recommend that you certainly go to that class. You will really go in deep and really deep into engine management and learn a lot of things. But I think for purposes of Continental and what I'm talking about tonight, I'm keeping it simple, and all owners can take what we're talking about tonight, and they can operate their engine safely, and they can operate it efficiently, and they can expect maximum durability out of it. So we want to operate and understand our pilot's operating handbook with regards to manifold pressure, RPM, CHT, EGT, TIT, and so forth and so on. You know, when I first got my first flying job as a 135 pilot, I really didn't know much about engine management. You know, you reached up there and the check airman pulled the fuel flow gauges back to 120 pounds a side or something like that, and I did it as a youngster. Heck, I was 22 years old and flying twins and flying people around, and gas was $1.50, $2 a gallon. Who cares if we burn a little extra fuel? And engine management wasn't really something that we dove into. But I also worked in the shop too. My employer found that I had an A&P license, and I had to do the Superman jump into a phone booth routine daily. I could go in shop clothes and work on airplanes, and then jump in the phone booth, put on a tie, and out I went to take a charter. And so engine management became something very, very interesting, that I became interested in, and I wanted to understand how we could operate the aircraft more effectively. And at that time, it was for speed, and so got to working with the mixture settings to maximize the speed in the form of best power. But make sure, folks, that you understand your pilot's operating handbook. You know, as a flight instructor, I've flown with a lot of people that don't understand their airplane. A lot of flight instructors out there don't understand the airplane. They're just coming out there to build a little time to fly with you and sign off a biennial flight review and get paid the $25 or the $50 or whatever the instructor's charging, so that he can build some time to get a right seat job in a regional airline. That's unfortunate, but it's often the case. We as pilots and owners, we should take it upon ourselves to make sure that we understand our pilot's operating handbook and that we're extremely well-versed in what those limitations are with regards to manifold pressure, RPM, and the things listed in the slide. We developed that through the pilot's operating handbook is developed through testing and the engineering that we did when we designed the engine, and we integrated that with the OEM, original equipment manufacturer, or the aircraft manufacturer. We integrated that together so that we have both test cell data and flight test data. So the operations manual for the aircraft, pilot's operating handbook, that's the higher TC holder. That's the higher type certificate holder. That's the Bible. That's what pilots should use and understand for operating their engine. The operations manual that's published by Continental Motors is a guide. Some of the engines do have altitude data and altitude curves, but for the most part it is test cell data. So make sure that you're using the pilot's operating handbook for all of your engine limitations. Tonight we want to understand very clearly some terminology, and we want to make sure that that we're using these terms in the right way. And this presentation is being recorded, and it will be available that you can go back and review. But it is critical that we understand the four terms that you see on the slide. Number one is maximum recommended cruise. Now, be careful with the wording, because there's a lot of pilots out there, a lot of owners that confuse maximum recommended cruise with maximum continuous power. They are two different things. I'm talking about maximum recommended cruise. That's the maximum power setting that you can cruise and have full leaning authority. I'm going to go into a little more detail on that in a minute, a couple more slides. The red zone, we've all heard of the red zone, the red fin, the red triangle, the area for which that demon lives out there that we can damage our engine. In the last year or two, I've learned by going to advanced pilot seminars, by meeting with some of the leaders of the Cirrus Owners and Pilots Association and Bonanza owners and all, that that the red zone or the red fin is actually defined differently within the culture out there, and means several different things. So when we talk about the red zone tonight, we're going to talk about that area that Continental feels you shouldn't run in, because the engine's not tested there for detonation margin clearance and for durability. So red zone may mean something different tonight than you're accustomed to. Detonation. Detonation is a four-letter word to us as aircraft owners. It can ruin our day. Detonation is a spontaneous combustion of the fuel-air mixture due to very high temperatures and pressures. It is not the same as pre-ignition. Pre-ignition can lead to detonation, but detonation, because of the high temperatures and explosive forces that are going on in the engine, can actually do damage to the piston, and it can erode the piston to the point where it becomes not where it won't work anymore, and a hole in the piston can start the aircraft or the engine working like a compressor pump, pumping the oil overboard out through the breather, and then we have an oil starvation event and maybe an off-airport landing or an accident in worst cases. So we certainly want to prevent detonation. By the way, if you have detonation, your engine has to come down and be inspected. I can tell you countless times when owners have experienced detonation, have damage to their engine, they've got molten material, melted piston material that's gone through the engine, and the mechanic goes out there and takes the cylinder off, replaces the cylinder and the piston, and away they go. Those detonation areas are extreme pressures that can hammer bearings, they can do damage to connecting rods, they can stress crankshaft journals and the crankshaft itself to the point where it can be very, very dangerous to continue use of the engine. And then engine parameters is something else tonight that we're going to define and talk about. So my maximum recommended cruise. Why would Continental Motors set such a limit? Again, folks, it's not maximum continuous power. It is maximum recommended cruise. That's a picture of the test cell readout. All engines at Continental are tested on a cell, and they go through a computerized run, and we look at that. Same way when we certified the engines, we did the same thing. Many of these engines were certified before computers, so they were done manually. But what does it really mean? Well, we developed a maximum recommended cruise. It's at the point where, again, if the cylinders are glowing at 460 degrees, the oil temperature is 240, and the inlet temperature to the induction system is at its limitation, detonation can be avoided. So what I'm saying is that if on a hot day I'm configured at those maximum engine parameters at or below max cruise power setting, I can't detonate the engine with the red knob. There's nothing that I can do with that red knob that will inflict damage on the engine. Now, what is that point? Well, in most Continental engines, it's somewhere between 65 and 85%, depending upon the engine model that you fly. Some of our turbocharged engines, such as the TSI 0550K that you'd find in a new Cirrus, or a TSI 0550C that you'd find in a Cessna Corvallis, or TTX now, those engines are turbocharged. They have lower compression ratios. They don't have 8.5 to 1 compression ratio. They have 7.5 to 1 compression ratios. And because the compression ratio is lower, we can run those at a higher power setting. those are, their maximum cruise power setting is 85%. If you look in the pilot's operating handbook, there's a maximum RPM and manifold pressure setting. And at that manifold pressure and RPM, if you're at that point or below, you can do anything you want with the red knob. And even on the hottest of days, at maximum engine limitations, you would not detonate the engine. And the engine is tested for durability. On the inverse of that, there's a lot of engines out there, such as, let's take the IO550N or the IO550B, the N found in the Cirrus and the B found in the Bonanzas. Those engines have an 8.5 to 1 compression ratio, and therefore their maximum recommended cruise power setting is a little lower. In some of those engines, it's 65 or 75% power. Again, we look for a manifold pressure and RPM combination that gives us that. It is put in the POH for the older aircraft. You may see a power chart in there, and it may have 2,400 RPM, 24 inches of manifold pressure, or 25 inches of manifold pressure, and then there's nothing above it in the chart. Well, that cruise setting is the maximum recommended cruise. They don't have a maximum recommended cruise for 30 inches and 2,700 RPM. Although that's a maximum continuous power setting, you can run it full rich, run it all day long if you want. The engine won't be very efficient, and it certainly won't be making all the power that it can, because we're not lean to best power. But we have a richer mixture, keeping it cool, and we can run there if you want. What I'm talking about is a power setting that I have full leaning authority of the engine, that I can in no way damage that. Detonation is avoided, and the engine is tested for durability. So again, not maximum continuous power, but maximum recommended cruise. Up to, but not to exceed that limit. Okay? Full leaning is safe, allowable, and the engine is tested for durability. So if anybody tells you that you're going to kill your engine if you run it lean a peak, that's simply not true. If you're at or below max cruise power setting, you can't hurt the engine. You can't burn it up at all. In fact, on the lean side of peak, which we're going to learn later, you can't hurt the engine. The pressures, the temperatures, things like that are way off the chart. There's some danger in that. We're going to talk about being very careful about the low pressures and low temperatures in next week in part 2 of this. But tonight we want to just understand these basic terms as we get into engine management. Okay, so red box, red zone, red fin, all of those types of things, that's the point above maximum recommended cruise where you could get into detonation. I'm going to say something. I want you folks to think about this. At or below max cruise power setting, there is no red fin. At or below max cruise power setting, there is no red zone or red fin or red box, according to Continental Motors. And I'm going to show you that here in just a minute on the simulator. When you're outside the red zone, you're not in that area, again, the engine is tested for detonation margin safety, and it is also durable. Detonation, that's a detonated piston. That's what it looks like. When the temperatures get extremely hot due to the combustion pressures and the spontaneous combustion that's going on in the chamber, it gets so hot that it can actually act like a blowtorch and burn the periphery of the piston. What that's characterized by for you as pilots as you're flying along is very, very high cylinder head temperature and very, very low exhaust gas temperature. I've done purposely set detonation off in engines in the test cell, and I've seen cylinder head temperatures climb to 890 degrees. Now, the cylinder didn't crack and blow off and all that type of thing, but the piston is the weak link, and the piston erodes the periphery, and then the engine acts like an air pump, and it pumps the oil overboard through the breather, and you have a oil starvation event, off-airport landing, and then an expert goes out there and looks at it and says, oh, the connecting rod let go. That's not what happened. It can be a detonation event. Extreme pressure, high cylinder head temperatures, and low exhaust gas temperatures. And I'm talking about extreme pressure. I'm not talking about normal combustion pressure. So don't confuse the fact that high combustion pressure, if I decide that I want to run the engine at best power, that I'm going to do damage to it. Again, the engine is tested for durability at a best power setting where I am developing peak pressures. What I'm talking about is extreme pressure that's taken off uncontrollably because the engine is now acting like a diesel. It's starting to ignite the fuel-air mixture just because of the pressures and temperatures that are going on in the combustion chamber. So it's very, very important that we understand that. I'm going to just show you the simulator that we're going to talk about next week and how it works, and then I'm going to take some questions. Again, I want this to kind of marinate over the week, and then we'll talk about these things in a little more detail in next week. This is a basic chart that we all have seen. We've seen it in our pilot's operating handbooks. We've seen it in our owner's manual for the engine. And there's always curves for exhaust gas temperature, cylinder head temperature, horsepower, and another term that we need to understand is brake-specific fuel consumption. That green line is the brake-specific fuel consumption. What that means is how efficient is the engine? How much energy am I deriving from a given amount of fuel? So I want to be at the bottom of that brake-specific fuel consumption curve. When I'm at the bottom of it, I'm at maximum engine efficiency. Now I can continue to lean and become very inefficient, think, okay, I'm burning less fuel, but I'm actually becoming extremely inefficient. Let me just show you that in this. This is the picture of the simulator. This is the simulator that we're going to use a lot next week when we talk about this, and I want to introduce that to you tonight. If you can see my mouse moving around here up in the right-hand corner of the screen, that's the brake-specific fuel consumption number right here, this 0.539, which is a very high brake-specific fuel consumption number. But you can see as we start to pull fuel away from that, I can bring that number down and the engine starts to become more efficient. We like to see something in a 0.3 or something like that. The engine is becoming very efficient. So this is how efficient my engine is. The lower the number, the more efficient. Up here in the dial is the horsepower reading. That's how horsepower. Remember, if I begin to lean, I'm going to get an increase in horsepower as I approach best power. And then as I go through best economy or lean of peak, I begin to see a dramatic reduction in power. So we need to decide as pilots, do I want to go fast or do I want to go far? It's very difficult to try to expect the engine, in an engine management point of view, to do both. We can be efficient in both settings, but we really can't go far and fast. Here at best power, we're developing a lot of power. Here past best economy, which is peak is about somewhere in here, past best economy, you can see that the horsepower is starting to really taper off. And a lot of pilots will continue to lean because, wow, look at my cylinder head temperatures are coming down, I'm burning less fuel. But what they don't understand is they're becoming extremely inefficient at that point because the engine is so far down on power that they're not running in the most efficient point that they can. In fact, if we go back to the chart, this is the brake-specific fuel consumption curve. we want to be right here where my little pointer is. That's where we want to be. If I continue to lean past that, this chart almost goes straight up, or this curve almost goes straight up as we become grossly inefficient. So here's the horsepower up here. This is my mixture control. This is my power setting here. And you can see I've got a red box in between best power and best economy. This is what we're going to talk about. If I lean next week, when we go through some of these practices, if I begin to lean through best power and I get in here and I've got the power set real high, I'm in an area where I could get into detonation. But as I bring the power down to maximum recommended cruise, you'll see that the box disappears, and there's nothing that I can do as a pilot in this area here to hurt that. So this is the mixture, this is the throttle over here. Here is the exhaust gas temperature, and this is the cylinder head temperature. I have fuel flow, and I have percent power. This simulator has been used by a lot of people. We developed it maybe a year or so ago, and we debuted it at Oshkosh. And pilots are reporting that they get a lot out of it, that it's a very useful tool in understanding what's happening in the engine, and it's something that I certainly want to share with you in great detail next week as we go through some of these practices. Again, I want to let that marinate for tonight, and at this point, Jeff, I'll take any questions so that people thoroughly understand this concept and these terms that I've talked about tonight. And next week we'll really get into the down and dirty of engine management. So we certainly encourage everyone to come back next week and get the part 2 of this webinar.
Sure. Thanks very much, Phil. And so we have a few questions that have come up. And one of the things that certainly comes up here is when you talk about going through that range, can you talk a little bit about what it means? Because you always have to lean through that range if you are in one of the power settings that has a red zone. So if you could talk a little bit about that for a moment, and then we'll get a few more in, and I'm sure there'll be plenty with the second half of this next week.
Certainly. Good question, Jeff. And so I'm back at the simulator, and I pushed the power up to, let's just say 100%. We see the red box. And so the question is, how do we lean through this where we don't do any damage? And those of you who have heard of the term the big pull, this is the big pull. Someone who is advocating running your engine at a higher power setting than 65%, actually, this Lena Peak simulator is based on an IO550N. So let me set that 65%, you see it goes away. But let's say, hey, you can run at 90%. Don't worry about what Continental says. You can run at 90% and you'll be okay. Just remember that as you lean, when you get into this point right here in the red box, you could get into detonation. So the advocate of running outside of engine limitations will tell you, you better do the big pull. That means don't dilly-dally in this area here. Don't delay. Get from this side to the back side of peak quickly. Now, look what happens to my CHTs and EGTs. EGTs are coming up, coming up, coming up, coming up. CHTs are coming up. I could get into an area where I could detonate the engine if I stay there for a long time. Now, going through there momentarily is not going to hurt a thing, but I better get over here on the back side of peak. And why Continental advocates this is you start to lean right here, you get right to this point right here, and ATC calls you for a reroute. And you're stuck right there having to really write it down. It's one of those that you have to really write down, and maybe you're stuck there, or the kids are fighting in the back seat, or whatever. There's a host of things that can come up. You don't want to be in that area. So that's why Continental advocates running at a power setting, maximum recommended cruise. Remember, durability is there too. And when you're running outside that envelope, we're protecting you both from detonation and giving you maximum durability. So the only thing I can tell you, is if you're going to run outside that envelope, you better make sure that you pull from here to the backside of peak where things start to come down and cool off, and do that very, very quickly. I hope I've answered that question.
And Bill, what about, there's a connection between the engine operation charts and the aircraft operation charts. What should people be looking at, or how should they be reconciling those two?
Good question again. There are engine operation charts that are really predicated on test cell data, Jeff. And so the pilot's operating handbook, the aircraft charts, are flight tested data, and that's what you should use. When the test pilot is out doing the certifying the airplane, he's doing mixture curves for both best power and best economy being lean to peak. And when he's doing that, or he or she is doing that, they're looking for in the area of best power, they're looking for the maximum twist on the crankshaft, the maximum indicated airspeed. When we're looking at the best economy, we're looking at the maximum miles per gallon that I can get out of the engine. I'm looking at airframe and engine combination that puts me at the bottom of that brake-specific fuel consumption curve. So to answer the question in short, which I tend to ramble, I'm sorry about that, but getting back to the question at hand is, you want to follow the data that's in your pilot's operating handbook. If you have an experimental airplane or you have something like that, a lot of times you don't have that type of data, so you have to take the test cell data that Continental provides, and you have to do that, kind of do some interpolation and some flight testing data on your own. If you have a supplementary type certificate where you've taken out an O200 out of a Cessna 150 and you've shoehorned an IO550B in it, the STC holder, and I know that's crazy, but if the STC holder should provide flight test data and a supplement to your pilot's operating handbook on how to operate the engine. Okay, and what about when you begin to lean? We're talking about different pressures and powers, et cetera, and you do that during takeoff. We've gotten different questions from people having to do with that. Any phase of flight, how does that work? Yeah, there are some aircraft that maintain, again in the POH, that it's full rich throughout the entire flight. One thing that you can do, and you can do it safely, is if you, on the takeoff roll, if you note at the elevation that you are that you noted the exhaust gas temperature, you can safely lean the engine at full power, at climb power, and continue to lean back to the exhaust gas temperature that you saw on the runway. As you, let's take for example a Bonanza, normally aspirated, pilot takes off and he notes, and I'm picking a number, 850 or 900 degrees exhaust gas temperature. As we climb, it starts down to 800 or to 775 or to 750. You can grab the red knob and start to lean a little bit and lean it back to the 850 mark, or what you saw on the runway, and you can do that safely without detonating the engine. You don't want to, certainly at maximum power or climb power, you don't want to lean into that red zone or lean into a best power configuration, because you could get into that unwanted area and cause some problems. So we want to keep the engine cool. We want a little extra fuel to protect us against detonation while we're at those high power settings. Great, thank you for that. And really, can you comment on the idea of when the roughness kicks in and how that fits with getting the best economy or running lean to peak and getting beyond that? Yeah, that's a very good question, and we're going to go into that in great detail next week. But let's say we set 85% power in this engine. I'm on the simulator again. I begin to lean, and we get in here to best economy where Continental Motors says to run, but we notice that, our cylinder head temperatures are 390 degrees, and I remember, reading an article Mike Bush wrote, and he said that the world would end at 380 degrees, and I'm picking on Mike because he's a friend of mine, but you take anything like that, and so the owner automatically thinks, well, if 380 is good, I'll probably do my engine even better if I lean further and cool those cylinder head temperatures down to 350. And now I start to get into a instability. I start to get into variability of the power impulses. I can start to cavitate rings. We're going to go into that in great detail next week. I can get the cylinder head temperature so low that I'm not affecting any heat in the engine and begin to have corrosion problems. So necessarily going to the point of instability is not a good thing. That's why when we all learn to fly in the Cessna 150s, 152s, 172s that are carbureted, we learn to lean to roughness and then screw the knob in till it ran smooth. And guess what, folks? You can do that with your brand new Cirrus or your brand new Bonanza or any of these airplanes. You can do the same thing, and that's going to put you in a best economy situation somewhere in here. We get to the roughness point, and then we continue to enriching until it runs smooth, and that puts us in the best economy mode. And we can do it without engine monitors and JPIs and things that along the way. And I'm not down on those things. I think those things have their place, and they're very good at indicating what's going on in the engine, but we can also safely lean the engine doing the old method that we all learned to do.
Great, thank you very much. And last, because I know we've got a big session coming up next week, a lot more information that I think will answer a lot of the questions that are coming up here now, which could be much more in depth. The biggest question we're getting, Bill, everyone wants to know, is do we just watch the simulator with you, or will this ever be released?
Yes, I'm asked that, and you know what? You just have to give me your credit card number, and I'll make it available. No, I have been asked a lot, and our legal department, I think, has reviewed it and will be releasing it soon, and it will be available so that people can utilize it. The EAA, Sun and Fun, they saw it debuted, and they actually want to put it in the museum as something that people can work with. So we've got a lot of pressure to get it released, but as with everything, it has to go through a legal review, and it will be available. And I hope that people find it useful. I tried to make it simple as can be, and again, it's all in the interest of understanding your engine.
Great. Well, thank you so much again for your time, and I ask everyone's patience on some of the questions because, again, we'll be rejoining for a really exciting second half of all of this at the exact same time next week, same day. You can also find that directly again on Social Flight. A recording of this presentation will be available tomorrow on the link on Social Flight, and you will also get an email following this that'll give you a link for that. So again, thank you, Bill. Thank you, everyone, for joining us this evening. We really appreciate it. Again, we're all here to promote general aviation and to help each other, help us spread the word about everything going on here tonight and about Social Flight. And please have a good evening and fly safe.
Thank you, Jeff.